All right, welcome. Today, we are diving into some really cool research about a new kind of AI. And look, this isn't just about making AI bigger or faster. It's about making it smarter and, way more honest by actually fixing one of its biggest, most dangerous flaws.
So let's just get right into the heart of the problem. We've all been there, right? You ask an AI a simple question, and it comes back with an answer that's super confident, totally detailed, and completely made up. This whole thing, what we call hallucination, is the big mystery we're tackling. Why do these incredibly powerful models we use every day just invent stuff?
To figure out the solution, you gotta understand the problem first. It's like we need to investigate the crime scene. And the problem really comes down to this fundamental paradox, this contradiction in how today's top AIs are even built.
This quote from the research paper just nails it. Even though these AIs seem like geniuses, their thinking process is, and I love this phrase, paradoxically shallow. It means they've seen pretty much the whole internet, but they can't actually think about it in a deep, meaningful way.
And you can really see that contrast here. On one side, you have this massive scale. They're trained on trillions of pieces of data. They can write poetry, they can code, they can chat. But on the other side, that depth is just shallow. They're amazing at spotting patterns, but when a problem needs multiple steps of logic, they just fall apart. You've heard it before. They're a mile wide, but only an inch deep.
So how in the world do you fix a paradox like that? Well, this is where our detective enters the story. The researchers behind this have come up with a totally new blueprint for an AI's mind, a model that is specifically designed to think deeply and maybe more importantly, honestly.
And here is the name of their creation. It's a mouthful. Get ready for this. Governed, self-adaptive, evolutionary, hierarchical, recursive, variational auto-encoder. Yeah, let's just call it GSA-HRV-AE for short. But hey, don't let that crazy name fool you. The idea behind it is actually brilliant and pretty easy to grasp.
The researchers gave us this perfect, simple definition. So if you forget the crazy long name, just remember this. It's a thinking machine that's smart because it thinks in layers, it gets better all by itself, and, crucially, it has to follow a set of safety rules.
So how does this machine actually work? What's under the hood that makes it so different? Well, it all comes down to 3 critical upgrades that are built right into its DNA, and each one is designed to fix one of AI's biggest weaknesses.
These 3 steps are really the whole story. First, it's made to think deeper, not just wider. Second, it's built to actually evolve and get smarter on its own. And third, it's governed by rules that keep it safe and truthful. So let's break each one down.
All right, this first upgrade goes right after that shallow reasoning problem we talked about. Instead of having just one flat thinking process, this AI has what you could call a recursive brain. It can loop back on its own thoughts to make them better and better. It does this with a 2-part brain. You've got a fast thinker that's all about the nitty-gritty details, and then you have a slow thinker that's looking at the big picture, the grand strategy. These two are in constant communication, passing an idea back and forth, refining it over and over, kind of like how you or I would mull over a really tough problem until we get it right.
Now, the second upgrade is just wild. This AI isn't just built in a lab. In a way, it's grown. The researchers took a page straight out of biology, using evolution to create a system that can improve itself. What they're doing is basically digital natural selection. It starts with a whole bunch of slightly different mini-AIs. Then, it introduces random changes, mutations, into their code. It tests all of them to see which ones do the best job, and then only the fittest ones get to survive and create the next generation. It's constantly running little experiments on itself and only keeping the upgrades that actually make it smarter.
Okay, and finally, we get to what might be the most important upgrade of all. This model is designed from the ground up to be trustworthy. It has guardrails built right into its core to stop it from making things up.
This right here is the secret sauce. It's a simple but really profound change in how the AI is motivated. See, current AIs are trained to always give an answer no matter what, but this model actually gets rewarded for admitting when it's not sure about something. This encourages it to just say, I don't know, instead of taking a wild guess and being confidently wrong.
And this is all managed by a super clever 5-level governance system, another idea they borrowed from how self-organizing systems work in biology. Each level has a specific job, from level 1 handling the basic data, all the way up to level 5, which is kind of like its conscience. It's constantly on the lookout for hallucinations, making sure the AI stays honest. It's a built-in system of checks and balances.
So that all sounds great in theory, right? A deeper, thinking, evolving, self-regulating AI. But does our new detective actually crack the case? Well, the researchers put it to the test, and the results are pretty darn compelling.
First, they tested it on analyzing text, and right away, this new design showed a 15% reduction in hallucinations. Now, you might hear 15% and think, that doesn't sound like a lot, but trust me, in the world of AI safety, that is a significant, really promising leap forward.
Next, they threw some really complex, gnarly data at it. Stuff like social networks or molecular structures. And not only was it more accurate, but its deep reasoning brain let it figure out the right answer 3 times faster than other models.
But this might be the most mind-blowing result of all. They gave it a set of famously difficult abstract reasoning puzzles, and this new model solved 45% of them. What makes that absolutely incredible is that it did it with a brain of only 7 million parameters. To put that in perspective, models like GPT-3 have over 175 billion parameters. This shows that a smarter design can be way more efficient than just throwing more power at the problem.
So what does all this add up to? Why should you care about this super complex new AI model? Well, it's because this research points to a future where we might actually be able to trust our AI.
The possibilities here are huge. In bioengineering, it could simulate incredibly complex systems. For robotics, you could get robots that can actually reason and adapt to new situations on their own. And in medicine, and this is a big one, it could lead to safer AI that analyzes patient scans without making up deadly details. In the end, this isn't just another small update. The researchers summed up their goal perfectly with this quote: "This is a real shift in philosophy. It's about pushing AI to be deeper thinkers, to be constant self-improvers, and to be dedicated rule followers. It's about building in honesty from the ground up."
And that leaves us with this final, really fascinating thought. For so long, we've measured intelligence by how many answers you have. But maybe the truest sign of intelligence, for us and for our machines, isn't knowing everything, but having the wisdom to know what you don't know.